This first lesson of 2.7 is going to be all about vocab, and then we'll kind of jump into some algebra later on. But there are quite a few words that we need to know for this section. The title of the section is Parallel Lines and Transversals. You already know about parallel lines. They're just two lines that never intersect. Transversal is probably a new word. A transversal is just a line that crosses over another set of lines. So that could be a transversal of those two parallel lines. And we'll talk about that a little later on. So just a review of the word parallel. Parallel lines do not intersect and are coplanar. You probably haven't heard that coplanar part of the definition of parallel lines before, because in past math classes you have just worked in 2 dimensions, so we haven't really talked about having multiple planes, but that is technically part of the definition of parallel lines. So in this diagram, 2 lines that would be parallel are X and W. You'll notice that those are marked with those arrows that I have in blue. It could be a double set of arrows like I have. It could be a single set of arrows. Those arrows could be shaded into and look more like triangles. You're just looking for the same symbol on each line to show that they are parallel. Not only can lines be parallel, planes can also be parallel. So, as you can probably guess, parallel planes are just 2 planes that do not intersect. So, in this diagram, plane P and plane Q are parallel. And this symbol that looks like 2 parallel lines means parallel. So parallel is a word that we already knew. Skew is a word that is probably new to you. Skew lines are 2 lines that do not intersect and are not coplanar. So in this diagram, line W and line Y do not intersect because line W lives above line Y. Similarly, X and Y would never intersect, and Z and W would never intersect. So there are a couple examples for you. So skew lines, 2 lines that do not intersect and are not coplanar. All right, let's identify some of those things. So which line or plane contains point T and a line parallel to DE. So DE would be from D to E. So we're talking about this line right here. A line parallel to DE that contains point T would be line CT. So this one. Next thing we're looking for is a line which contains point T and a line that is perpendicular to CD. So CD is right up front here. Remember, perpendicular means to make a 90-degree angle. I see a 90-degree angle right there. So that line would be TC or CT. That's the same thing. Next thing I want is a line skew to CD that contains point T. So a skew line has to be on a different plane and would never intersect. So CD is up front. A line containing point T that's on a different plane would be that one right there. That is line TG. And I've got one more. I'm looking for a plane parallel to plane DEH. So DEH, I've already got it shaded in, but it's going to be this side of my box. So a plane parallel to that would be the plane on the other side, because those two planes never intersect. And I called that plane TCA or plane ACG. Either of those work. You're just looking for 3 points on that plane. If you're not taking notes already, I'm going to have you take out a notebook. You might want to just pause the video right here and do these 3 steps on your own. So you're going to use your protractor to draw a pair of parallel lines, then draw a transversal, so a line that intersects those 2 lines, and then you should have 8 angles created. Go ahead and measure those 8 angles. And your picture might look a little different than mine. So your angle measures might be a little different than mine. But hopefully you notice a pattern when you do that. So if you haven't, pause the video here and actually do it. All right, so you'll notice that even though I've got 8 different angles here, I only have 2 different measures. All of my angles are either 50 degrees or 130 degrees. So that's kind of the unique relationship that exists within parallel lines and transversals. And on the next couple slides, we'll see that all of these specific angles, 1 through 8, have names. So if 2 parallel lines are cut by a transversal, then we have something called the alternate interior angles theorem. So we get a couple things from this name. Alternate in your brain probably means like opposite. So these are things that are on opposite sides of the transversal. And interior in your brain should mean on the inside. So let's find these. Interior would be our inside angles. So angles 3, 4, 5, and 6 are my interior angles. And my alternate interior angles are the ones on opposite sides of the transversal. So angle 3 and angle 6 are a set of alternate interior angles. And angle 5 and angle 4 are a set of alternate interior angles. You might notice a relationship between these 2 angles. You might notice it from your drawing. You might be able to notice it just by looking at the picture. These 2 angles are going to be congruent. So angle 3 will be congruent to angle 6, and angle 5 will be congruent to angle 4. So the alternate interior angles theorem just says alternate interior angles are congruent. Next, we've got the alternate exterior angles theorem. So we already know alternate is opposite sides of the transversal. Exterior should probably make you think outside. So my exterior angles in this diagram are 1 and 2 and 7 and 8. Remember, alternate is opposite sides of the transversal. So angle 1 and angle 8 are going to be alternate exterior angles. And angle 7 and angle 2 are going to be alternate exterior angles. Look back at your diagram if you need to figure out the relationship between these. Alternate exterior angles are always congruent. So angle 1 is congruent to angle 8. Angle 7 is congruent to angle 2. The alternate exterior angles theorem just says alternate exterior angles are always congruent. So we've got 2 more relationships that exist within parallel lines and transversals. One being consecutive interior angles. Consecutive should make you think like together or the same. So consecutive interior angles are on the same side of the transversal. And again, interior is on the inside. So our interior angles here would be 3, 4, 5, and 6. Angles 3 and 4 are on the same side. So those would be consecutive interior angles. Or sorry, not 3 and 4, 3 and 5. And my other set of consecutive interior angles would be 4 and 6. This one is a little bit trickier to tell the relationship, but you might be able to figure it out by looking back at your diagram. Consecutive interior angles are supplementary. So the measure of angle 3 plus the measure of angle 5 should equal 180 degrees. And the measure of angle 4 plus the measure of angle 6 will equal 180 degrees. So the consecutive interior angles theorem just says consecutive interior angles are always supplementary. And then the last type of angles we have are corresponding angles. Corresponding in your brain should be like a shortcut word for the same spot. So you'll notice that I have kind of 2 sets of 4 angles that are formed when I draw my parallel lines and my transversal. Angle 1 and angle 5 are both the top left angle in their set of 4. So angle 1 and angle 5 would be corresponding angles. Angle 2 and angle 6 are both the top right. So 2 and 6 are corresponding. Angle 3 and angle 7 are both the bottom left. So angle 3 and angle 7 are corresponding. And angle 4 and angle 8 are both the bottom right. So angle 4 and angle 8 are corresponding. And the corresponding angles postulate says corresponding angles are always congruent. So 1 is congruent to 5, 2 is congruent to 6, 3 is congruent to 7, and 4 is congruent to 8. And so you'll notice with all these different angle measures, we've really only got 2 different angle measures going on. We know that consecutive interior angles add up to 180. So if you have just one angle measure and you're told that you have parallel lines and a transversal, you can figure out all of the other angles because our corresponding angles are the same, our vertical angles are the same, and then we can use consecutive interior angles to figure out one missing angle by subtracting from 180, and then we can put on our vertical angles and our corresponding angles. So when you have a set of parallel lines and a transversal, you literally need one angle measure and you're able to figure out all 8 angles. For tomorrow, I would recommend you know those vocab words just from these last 2 slides. So given a picture of parallel lines and transversals, you should be able to identify 2 alternate interior angles, 2 alternate exterior angles, 2 consecutive interior angles, and 2 corresponding angles.